All right, well, there are only a few days of Codevember left, so we are nearing the end of this month's experiment of creative coding, and for me, streaming every single day. So today is November 28th, 2016. Today, I was inspired by this Codevember submission you see up on the screen by Jack Rugile. And I want to try to do something similar today in Elm using the Canvas or the Elm Graphics API that uses Canvas. And I'm not sure how the performance is going to be in Elm and how many particles we'll be able to handle without things coming to a crashing halt. But let's give it a try and see what we can do. And yeah, I also wanted to show this other sketch by the same guy, Jack Rugile, another cool one. He has some pretty cool stuff up on his CodePen. So I will have the links to that posted later. Actually, I'll put this one in the chat right now. So let's get started and see what we can do in Elm. So I already have a new empty folder. Let's see, I've got Elm 0.18, so I'm just going to run elm-make to install our basic dependencies. And we are also going to need elm-graphics. That is evancz/elm-graphics. And let's start up our editor. So first things first, let's make our main.elm, new file, main.elm, and let's see, what do we want to do here? We're going to need a canvas, or I guess the way we work with Canvas is we'll make collage forms, then we will turn that into an element, and we'll turn that into HTML and we'll display it. I guess let's also start off by defining a bit of our model as well. So let's see, we're going to have a particles that'll be flying around on the screen. Each of those are going to have a position. Let's see. I guess we probably want to store these all as vectors using the math.vector2 module that we were using yesterday. That seemed to allow some pretty easy manipulation using vector math. So I think I want to import that math.vector2, and let's just expose everything from there. And we're also going to need to install the Elm community/linear algebra package, is the one that contains the vector types. Okay, so we'll have a position, which will be a vector2. We'll have velocity, which will also be a vector2. And what else? I guess that might be all we need for the moment. Let's start with that, and we'll see if we need anything else later on. We're also going to have our model, which is going to have particles, which will be a list of particles. And our initial model, we'll probably want to randomly generate this later on. But for the moment, let's just set up one to start with. So we will have a particle, which will be a vec2 of, let's say, 0, 0, and a speed of 5, 5. And let's have a second one, which will be a vector2 at 10, 0. And a speed of -2, 3. Okay, just a couple arbitrary numbers I made up. Then, oh, and I forgot to put this in a model. Particles equals that. Okay, great. Then, what else are we going to have? We're going to have a message type, and we're going to have time ticks, which means we'll need to import the time type. And we're also going to need, in a few minutes, the animation frame package. So that means we'll also need to install that. elmlang/animation frame. And that provides us a subscription that we can use to animate with. Okay, then we're going to have our update function. And that is going to take a message and a model, and we're going to case on the message. And if we get a tick message, then we're going to do something later. Actually, we can just write this for the moment. So we're going to take our model, and we're going to change the particles. And to change them, we are going to list.map over our current particles. And for each one, we will call particle.move. So I think, or I guess we could say update. So I think we're going to have a separate module. Let's pull that out right away. New file, we'll have particle.elm. And this is going to have the type in it, and it's also going to have an update function. So we will import particle exposing particle. And then particle.update, we are going to need to define. This is going to take a particle and give back a new one. And later, if we were doing this for a real sophisticated project, we might want to take the time delta here so that we could calculate accurately, but we're just going to do one movement per frame and not worry about the timing of the frames. And this is just going to take the particle for the moment and add the velocity to the position. So position equals, and we'll also need to import math.vector2 and expose everything from there. So we're going to add the particle position, and actually I want to write it this way. We're going to take the particle position and we will add to it the velocity. Okay, so that's our starting update function for our particle. And that's our update function for our main. We're just going to call particle update on every one of the particles. Then we're going to need our view. So let's just put a placeholder in for the moment. HTML.text of toString model, and we will write our actual view in just a moment after we write our main. So our main is going to be a program. It takes no flags, and it uses our model and message types. And this is going to be html.program. Our init will provide the initial model and no initializing commands. Our subscriptions is always going to return. We actually want to hook this up. We want to use animation frame.times and produce tick messages on every animation frame. Then update is our update function and view is our view function. And it looks like we need to import HTML. Oops. All right, that compiles. So let's start up Elm Reactor and load it up. Okay, so we have some particles moving around, so let's get these rendering. And actually, now that I'm thinking about it, these values are increasing extremely quickly. So I think I'd like to pass a float, which is a step, or I guess a t that we're going to multiply by, and we will scale the velocity by t. So here when we update, I'm just going to update by 1, let's see, so the velocity will be in pixels per millisecond, 2 pixels per millisecond. Let's see. No, that's too slow. Okay, I'm actually not sure what units these are in. Okay, but now at least the position is moving relatively slowly, so we won't see things just fly off the screen when we render this. Alright, so let's do our actual view. So we are going to have a collage.collage of some width and height. I like to use 750 by 500 pixels just for the stream, since it kind of fits in my preview window. And then we're going to use element.toHTML. And before that, we need to have a collage.group, I think. And in here, we're going to have some line segments. And it's been about a week since I've worked with this, so let's look up the docs. So collage, I think there's a thing called segment. Yeah, so we can make a segment that goes between 2 points. Then we'll get a path, and then somehow we can use a path to create a form using traced, and then we give it a line style. Okay, and for line style, there's one called solid that takes a color and gets a line style. Okay, cool. So we are going to use collage.segment. Let's just draw one from 1010 to 00. Then we are going to collage.traced and use collage.solid with color.red. So let's start with that. And once we have that actually drawing and positioned where we expect it, we will actually use our real data. So we need to import collage and element, both, and color. And collage.collage actually takes a list of collage forms, so we don't need to put them in a group. Okay, and that might be hard to see. Oh, hey Proton, you are the first comment in chat today. Welcome, and congratulations. Okay, so we have a tiny red line on there. I would actually like to make this thicker. So I think we're just going to have to pull out our whole line style. So rather than solid, we are going to stick this in. Our color is going to be color.red. Our width is going to be like 5. Line cap is going to be collage.flat. Our join is going to be, it doesn't really matter. Let's use clipped. Do I program Elm full time? Kind of yes and no. At No Red Ink, all of our new front-end code is in Elm, but we do have a bit of legacy CoffeeScript and JavaScript, although not a ton anymore. And we do have a couple like little JavaScript files that kind of connect Elm to other parts of the app. And then we also have a backend in Rails, so I do a lot of, well, not a lot either, but I do some Rails development as well. So I try to do full stack work when I can. And dashing is empty, dash offset is 0. All right. There we go. Okay, so that's a thicker line. Still, sorry, not that interesting in the preview window. All right, so now let's pull this out into draw particle. And I guess we can just list.map over that right from the beginning. So we are going to take our model.particles, map them all, and then stick them in a group. And I actually do want to use a group here rather than putting a list at the top level, because I'm going to want a background color as well. And then draw particle is going to take a particle and give back a collage form. All right, and then this is going to be, let's see, is there a 2-tuple in the linear algebra package? That would be nice if there is. 2-tuple. Yes, awesome. So here we are simply going to use 2-tuple of particle dot position. And what are we using for the other coordinate? I guess 0, 0 for the moment. Let's just see how that looks. Okay, so the particles are moving. And let's speed them up a little bit. There we go. Okay, so we're not drawing them properly. What do I think of Golang as a language? That's an interesting one. I used to work at Pivotal Labs, and they were getting really big on using Go, especially on new Cloud Foundry projects. And I guess, I don't know, I was always kind of torn about Go. It seems like kind of a clean syntax for a language, but it also, I think, doesn't solve a lot of the problems with safety and maintainability. Like, I feel like it's almost as easy to make things go wrong in Go as it is in Ruby. It's just like you have a kind of a faster runtime essentially. So I haven't actually used it that much, but I don't know, I feel like it was kind of a hot language, but I haven't really felt like there were a ton of benefits to it beyond, like, I don't know, I feel like there's more hype there than actual value. I think, I don't know, I've personally been more interested in looking at Elixir as a language for building backend tools, but again, I haven't really worked long-term on any projects that use either. I guess one of the nice things about Go is it's relatively easy to make cross-platform binaries compared to some other languages, or at least that's how they were using it for Cloud Foundry tools. And I totally learned Haskell because of Elm. I started working on Elm format about, when was that? I guess more than a year ago, last August, I started working on Elm format, and I had to learn Haskell to work on that. So I did not know Haskell at all before I learned Elm. Okay, so I think what I want to do for this segment is make the length of the segment be proportional, I guess, to the velocity of it. So we'll make two little points, and we'll have 2 tuple A and 2 tuple B here. And A is going to be the particle position plus the velocity. And we might have to scale that a bit, but we can worry about that later. And B is going to be the position minus the velocity. All right, let's try that out. Okay, and we are already running into this problem where collage forms, when you render them, are always centered. They don't get placed where you actually tell them to draw. They're always centered around a certain area. So I still do not understand why the API is like that, but let's see if we can fix it. So we are basically going to, let's see, and did I do this right? Yeah, okay. So let's try this. Let's see. Whoops. Okay, I want to look in here for transforming so we can move it. Yeah, okay. So we're just going to have the particle velocity be the first position, and we'll have scale -1, or I guess there's actually a function called negate in the vector library. And then we will render that, and then we will collage.move it to the position, to tuple particle.position. Let's see if that works. Math.vector2.negate. Okay, that is working. Let's see. Proton asks if I've ever felt to get something done I have to get around the strictness of the functional programming philosophy. I would say I felt like that a bit when I first came to Elm, which was in Elm 0.15, I think, when there were still signals, and there was kind of, you had to think about things in a way, excuse me. Yeah, back when Elm had signals as one of its core concepts, you had to kind of think about everything in terms of signals at the top level of your program. But currently, I haven't had problems doing that in Elm. Like, it's been very natural for me to kind of think about things in terms of the data structures and like model the data and write out type annotations for functions I want to write and then implement things from there. I would say the biggest problem I've run into with Elm is the performance for different things, mainly when I've been trying to do like graphic animations using SVG with lots of elements. Things have not been that great, and I think that could probably be optimized in the future, but that's been the main area with Elm where I've felt like I've had to kind of change my mental model of the program to actually get it to work, just when doing performance stuff with lots of SVG DOM elements. But yeah, I guess before Elm, I mostly was like, I was very much into object-oriented programming, and like I did a lot of Android, Java development, and iOS stuff as well. And I feel like kind of functional programming just forces you to kind of think about your data as being separate from the actions that operate on the data, whereas with object-oriented programming, you still think about those two things, but you also often conflate them together. But yeah, overall, I haven't really run into problems with the mental model of functional programming while working with Elm. All right, so we have rendered our colors, or rendered our segments, or our particles. So now, let's do something interesting with these. So maybe the next thing we should do is randomly generate a ton of particles, because I don't want to type out more, and I think I want to see more on the screen. So, when we initialize, let's fire off a random.generate, and we will make a random particle, and we will, when we're done, we're going to make a list of these, random.list, and let's try making 50 of them for now. And when we're done, we will, what are we going to do? We're going to produce a message. We need to define a new message type, or a new message constructor tag. That'll be called new particles. And we need to define that. That's going to get a list of particles. Just particle. Okay. And when we get new particles, we are going to take our model and replace the particles with the new ones. And we'll have command.none. And then also, I think I am going to put this in the particle package, particle.random. We'll stick that in there. And then we also need to import random here. Okay, cool. So then we just need to define particle.random. We are going to import random for that. And this is going to be a random generator of particle. And this is going to be random.map2 using our particle function. And we need a position, which will be, let's see, how do we want to generate these? I guess this can just be random vector. And I guess we want to give a range. Let's see. So let's define this. Random vec is going to be a random generator of vec2s. So I guess we should call this random vec2. And this is going to be random.map2 of the vec2 constructor with a random.float between, okay, so we're going to have two tuples in here. So we'll have min x, min y, and max x, max y. Min x, max x, and random.float min y, max y. Okay. And here, I guess we should probably ideally pass those in, but I'm just going to hard code these in the generator for now. So we want negative 375, negative 250 to 375, 250. And our velocity is going to be between -10, -10, and 10, 10. And, oh, I typed this wrong. These are the names that we're destructuring. And then these are all going to be floats. All right. Okay. Let's see if we can do way more than 50. Let's try 200. Okay. That seems to be going fine. Let's try 500. Okay, that seems like it might be lagging slightly, but it might be handling it just fine. I'm going to bump this down to 200 for the moment, just while I'm streaming. And, great. Okay, I think what I'd like to do is whenever we update, let's also filter out the particles that have moved out of the list. And let's see. So list.filter, we want to say particle.inbounds, and we will pass our window -375, -250 to 375, 250. Okay, and we'll only keep the particles that are in bounds. We will define this as a function. I'm going to put it here. And this is a function that takes two tuples of floats and returns a bool. It also needs to take the particle. And we'll also give these the same names, and we'll take the particle. And we're going to say we want the, let's see, do we have any helper functions in linear algebra that are useful here? We have just the getx and gety. Okay. So we will say if, actually I'm going to use a let statement. So x equals getx of particle.position, y equals gety of particle.position. Then we can return x is greater than or equal to min x, and x is less than or equal to max x, and y is greater than or equal to min y, and y is less than or equal to max y. Okay. And what did I mess up? I forgot a comma here. Okay. So, and then our final thing is in our animation frame, we only need to run the tick if there are particles on the screen. So we'll say if model.particles, if list.length of that is greater than 0, then we will do that. Otherwise, we will have no subscriptions. Okay. Just a nice cleanup, so once everything moves off the screen, the animation frame timer will stop. And then, finally, we want to potentially create a single new particle. And I guess we'll do that here. we'll say if model.particles, and the length of that is less than particle count. So let's pull that up to the top. Particle count. And particle count will equal 200 for the moment. So if we have fewer than that, then we will generate a new one. And if we have enough, we'll do nothing. So if we need a new one, we will random.generate, add particle with the particle.random generator. And then we need to define this as a new message, particle, and then we need to handle that. Add particle, and for this, we will basically take this, except we're going to add it to the beginning of the list. All right. Okay, and that looks like it's working to me. I'm seeing new particles pop in. All right, so now let's actually do something interesting here, rather than just having random particles. So in the example that I showed as our inspiration for today, the author uses simplex noise generator to generate kind of turbulence in the velocity and change the velocity of the particles throughout. So what I'd like to do is do something similar, but I don't have a noise generator that we can just use, and I don't really want to implement one today. So I want to just use some function that we build using sine waves, and have that so whenever we update, we are going to modify the velocity. So we'll change the velocity to equal particle.velocity, and we will add some vector, which is going to be, let's see, I guess we'll call it the change in velocity. So then we just need to write a function to calculate this. So let's try out a couple things. I think we just want to make a vector 2 with an x and y component that are based off of sine and cosine in some way. So let's try something simple to start with, and let's base things for the moment off of the position of the particle. So let's change it by the sine of particle.position, and we'll take the x position. I guess let's pull these out. X comma y equals 2 tuple particle.position, and then we can take the sine of x and the cosine of x. All right, so let's see. Okay, well, everything's wiggling. So that seems like it's working out. So we want things to be slower, I guess, or have lower frequency noise. So let's divide this by 20. See how that works. Okay, well, that's definitely doing something. I think I'd like to shrink how long these particles render. Let's see, so we're using at the moment the velocity as their length. So I'd like to make them a bit shorter. So we will scale by maybe 0.2. And I'll change this one to be scale as well. Let's see, what's going wrong here? We didn't define a type annotation up here. That's fine. Oh, this can be an int. Great. Yeah, okay. Cool. So that seems alright. Let's also change the generation so that they start with less of a velocity initially. Okay. So that looks alright. Let's start cleaning this up a bit. So I want a different colored background, first of all. So what do we have? Is there a rectangle? I think there's a rectangle in here. Yeah, okay. So we'll make a rectangle, 750 by 500. We will collage.fill that with color.blue. No, it's not a good color blue. Let's do color.hsl of, I think, like 60. Oh yeah, and this needs to be in degrees. Uh, 160. How about 120? No, okay. I'm gonna pull up my HSL picker. 216. And let's make this a bit lighter. Okay. And then let's also calculate the color of the particle based on, let's see, maybe like based on the distance from the center. So let's use color.hsl. We can use 0 for the hue, we don't care, 0 saturation, and the lightness will be the distance. Well, let's see, we don't really want the distance, we just want the length of it. Length, there we go. So we will take the length of the particle position, and I guess we need to divide that by some amount, like 200. Yeah, okay, maybe even more, 500. And let's make these a little skinnier. Yeah, okay. That is looking alright. And I guess let's also bump up the number of particles again. See if my computer can handle this while streaming. So I like how that looks at the beginning, and then things get pretty, What's the opposite word of dense? Strung out. But I think that's a good start. Let's try adjusting some of these parameters a little bit. So let's scale this by 0.2 and have it have less of an effect as the particles start out. And yeah, I'm going to see if I can bump up the particle count to like 2,000. This might be go badly. Oh yeah, that is not doing so well. But you can see kind of some nice patterns emerging there. But yeah, that's way too many particles for the moment. Whoops, I meant to put that at 200. Yeah, 200 seems to do all right. Okay, so let's bump this up a bit more. And let's also add a few different things on here. So let's see. One thing I'd like to do is have this kind of change over time. And currently we're adding a time step being passed in here. I think I'd also like to pass the overall total time. And to do that, we'll have to keep it in here. And we'll start it out at 0. And then in here, we will also update it. And then we'll also pass it here. So we can use this as a parameter that varies over time. And the way I want to use that is, I guess, add it in here. Yeah, okay. Seems alright. Maybe what we can do is take the absolute value of this in one of the directions. So let's see, I'm not super happy with how this is looking, and I'm trying to think through what exactly this algorithm is going to be doing. So we're making a random, well, not random, but based on the position, we are creating a vector that's a function of the x position at the moment. And that vector is going to kind of go in a circle as we traverse back and forth. Okay, let's take this one off for the moment and just use 0 for that and see what this looks like in just one dimension. Okay, so that's kind of making everything speed up and slow down at different points depending on where it is. Let's scale this up a bit and see the effect larger. Okay, so let's play around with some of these variables a bit. So if we make this smaller, okay, that looks a bit nicer. Yeah, okay, that's more of an effect that I was hoping to get, where we kind of see all of the particles, or at least a group of particles, start to kind of move in the same direction for a bit. I think the problem here with the equations I'm trying to write is that it kind of takes some fine-tuning of the balance of these different constants to actually get a value, or some values that get that grouping and doesn't have one parameter overriding the others. Yeah, okay. This is actually looking pretty good. So the other thing I wanted to try doing was putting in some, I guess, different harmonics into this. So if we take what we have here, and then we also add, I know what we can do. We can scale this by a different amount based on maybe the Y position, which will also shift over T. So this will be like Y over 200 plus T. And we'll probably want to scale T as well. That is way too much. Maybe this should be a plus sign. Let's try that. Or how about this even? Let's just take the sign of T, and then the whole thing will kind of shift directions over time. And for that, I think we're definitely going to need to divide T. Okay. So I think we're seeing periods of, yeah, I guess I'm not sure. It would probably be worth the time at this point to make like a debug view where we can actually like see the vectors for these changes in velocity that are being applied at each level. Because yeah, I'm having a hard time visualizing just based on the equations what's going on. Maybe the other thing we can do is animate the background color over time. So let's see, where did we render that? Here. So let's animate this. So this is going to be 0.5 plus 0.3 times the sine of model.t. And we'll probably want to change that. Yeah, and then we'll divide model.t by some amount, maybe 1,000. And let it just change slowly over time. Maybe a bit faster than that. Cool. Well, I am not 100% pleased with how this turned out, but that's all the time I have for tonight. And we did get to play around a bit with particles in Canvas in Elm and get a sense for about how many it can handle. I'll try bumping this number up again later when my CPU is not busy encoding video, but it looks like we can at least reasonably render 500 particles without a problem, even while streaming. And once I stop the video encoding, I can probably bump it up to at least 1,000. So yeah, thanks for tuning in. I guess there's 2 more days left for Codevember, so if you have any ideas for me, let me know on Twitter. And thanks for checking it out. If you're doing any cool projects in Elm, let me know as well. And I will see you all next time. Have a great night.